Yeah, good morning, good afternoon, everyone. Welcome to the webinar today. We'll just wait a few more seconds so that everyone shall walk in. Yep, I believe we have the audience now. So welcome everyone for the webinar today on how to avoid IoT pitfalls in Industry 4.0 adoption. And I will hand it over to Ram to begin the proceedings for the today. Ram, over to you.
Oh, thanks, Jatin. Thanks a lot for that. Again, welcome everybody. Thanks for joining us for this webinar on IoT, IoT pitfalls specifically. Before I get into the topic, I just wanted to give a quick introduction to who we are. I think some of you might have already be familiar with our organization, but at a high level, we're of course a services and a solutions organization. We're a mid-sized organization, publicly listed. We're close to 1,600 people worldwide, and we have operations here in the US, of course in EMEA and definitely in APAC. We have a very wide portfolio of services and technology solutions. Everything from open source solutions and applications development all the way to SAP, but also emerging technology in the middle. At a high level on our IoT expertise, we definitely work with a lot of our customers. We have marquee projects, building new business models for our customers in IoT. I will bring up one of the success stories later in my presentation. We also have a product that we have developed and have taken to market, very specifically addressing use cases for oil and gas industry on the upstream side. Definitely, we'll be looking forward to hear from you. This presentation that I'm going to share today will be sent to you for your reference. Along with it, you will see some information about our organization that you'll have a better reading as well. Quickly on the subject for today is of course not specifically IoT or IoT. They're pretty much the same. I will also touch upon very specific use cases for IoT. But overall, the lessons learned and the pitfalls is the subject. What happens to many organizations when they embark upon their IoT journey. So to start off, we know I think in 2021, this year, there are more devices connected to the internet than people, and the gap continues to grow. Last year, we ended with about 4 billion internet users worldwide, while we have close to 7 billion devices connected already. End of 2021, there will be more than 10 billion devices connected. When we say devices, yes, Internet of Things. So to overall measure the IoT business opportunity, I think the estimated market right now is about 150 billion, about like 2 years ago when the reports were published. But they're looking to to see a huge, tremendous increase in the next few years, and by 2025. The market will exceed 1.5 trillion. That's almost tenfold increase in 4 to 5 years. Again, many people still think IoT devices and wearables are invasive and a huge privacy concern. Sure, Dilbert didn't have any clue when they gave him the smartwatch, but most of the hurdles, most of the pitfalls in an IoT project or pilots that enterprises embark upon is usually to do with a lot of the unknowns. Here you can see Valley says sometimes it's all about the journey. I don't think that works. Our bosses, our business stakeholders would never allow such kind of answers for sure, right? We are supposed to know it all before we ask for budgets and sponsorship. So most of the time we are supposed to get it right, but the technology surrounding IoT is changing at a very fast pace. I don't know if some of you might have been familiar of these Gartner hype cycles. Yes, for IoT in 2020, it is reported that IoT is quickly entering into slope of enlightenment. But that's misleading a little bit because most of the relevant aspects of IoT when it comes to actual implementation, like the elements of IoT security, like the elements of the edge architecture, like the maturity of some of the commercial IoT platforms, they are still right now diving into the what they call trough of disillusionment. So that means there is still time for maturity in some of these elements of IoT. Most of the time, again, as I said, the standardization and things like that are still developing and maturing. And I'm most thought leaders say that's why whenever you want to do IoT implementations, think big, but start small in IoT. So educating ourselves for these trends and market forces and learning from others' mistakes and successes as much as we can is the way ahead. So in this session, I will try to educate you as much as I can. I will first start discussing some current trends in IoT business use cases and how best to build one of your business cases in your organizations. What does it take to entail? What are the right elements to build a business case and so on. Later on, I will touch upon a high-level solution architecture of a typical IoT solutions, and finally walk you through a customer success story. So to start off with, of course, there are various industries that are leveraging IoT nowadays. On the manufacturing side, predictive maintenance, or of course, we all know of the most popular connected cars nowadays, electric cars, but much more connected cars like in Tesla. Of course, connected fleets, trains and other infrastructure is getting connected. But we have to understand IoT has a huge demand right now in pretty much each and every industry. I think to go into specifics, take an example of banking. The new concept of US financial institutions is called Bank of Things. Again, it's evolving still. It refers to global IoT in business infrastructure that allows individuals and legal customers to exchange financial data within a single network. I think something like avoiding banks altogether, which links all personal IoT devices and things like that. And contactless payment, of course, is the start of such a IoT initiative. But more than banking, agriculture is one big area in which IoT solutions are very popular. Of course, we all know the population of the planet continues to grow. And definitely the resources are not unlimited. Definitely land, water, and natural components are being stretched. We are hearing about the stories in our West Coast. So again, in agriculture, the investments have gone up 60% in the last 4 years. All the way from field and soil sensors, connected combines, but also monitoring the wellness and growth of crop and yield, and actually activating harvesting programs or even weed and pest control is the areas of interest for many solutions that are being developed. Oil and gas, they have always been in the forefront, especially being able to monitor and manage infrastructure in various remote locations. Yes, security is a big concern. We have heard of those stories, and that created a big backlash in our East Coast fuel supply. So those definitely are in areas that oil and gas has already been using a lot of IoT-based solutions. Healthcare is a field where IoT ideas have been implemented since 2016, 2015 onwards. But majority of healthcare institutions were using more like Internet of Things devices, wearables are the right term for that. Primarily addressing use cases like patient monitoring, remote healthcare. Uh, um, I think pretty much every second IoT device in healthcare is a device for remote operation and control. A lot of big players are entering into this market, providing for infrastructure and connectivity for remote healthcare is the big norm nowadays in healthcare. Another big area, both smart buildings and smart cities, they go hand in hand actually. We've seen extensive implementation of smart buildings and infrastructure projects within new building construction. It's not only about again building access control, having energy management, having reactive lighting management, but more so with fire and life monitoring, smart cameras, keyless access control, cybersecurity. All these are aspects of smart building implementations. And in the recent few years, most commercial buildings, especially in the cities, are looking for enabling small cell enablement, small cell in regards to the 5G broadband networks that are being implemented. Now, smart cities on the other end are dealing with use cases like integrated HD video surveillance, cognitive intelligence, for emergency call stations, auto detection of gunshot and explosion. Those are big use cases as well nowadays. Of course, integrated security lighting and implementing other infrastructure projects like typically public transportation management, of course, interactive digital signage, real-time traffic flow. That's a big use case in connected cities and smart cities. But also overall collecting data from the smart buildings, from the streets for crowd management. And also sometimes we have seen smart cities implement what they call pedestrian analytics, with visual analytics and such to generate data that they can eventually derive some monetization models around them. They can sell those pedestrian analytics to commercial businesses, for example. So that's the kind of use cases we are seeing in IoT. Definitely, it's a huge explosion of leveraging IoT. The bigger area of interest, of course, the leader in IoT is the industrial IoT. The manufacturing sector again, we can call it IoT now, but you have to understand most of the manufacturing maturity has already been in that phase of automation for more than 2 decades now. So if you go to any modern manufacturing facility, you will see majority of the shop floor operations, there is a lot of automation in place already, right? You will see huge computers involved in majority of the machinery or the work zones. So IoT is evolving still in the industrial sphere. It is predicated on IoT, that Industrial Internet of Things, IoT, acts as a catalyst for revolution in Industry 4.0. So Industry 4.0 is the term for which they are talking about nowadays lights off manufacturing. That means factories will run without any people in them. Of course, most of us we are familiar of robots in, say, assembly line, robots being leveraged in paint line and things like that. But more than those heavy machinery, even smaller sensory elements, or even enhancing machine-to-machine communication are the elements of new age IoT devices and architecture that brings in what we typically call big data that gets generated, or analyzing the big data into AI ML algorithms and deriving insights that can be taken to real-time action are the use cases that we talk about in IoT and Industry 4.0 nowadays. Of course, predictive and prescriptive maintenance to eventually reducing your unplanned asset downtime and increasing the overall equipment efficiency is the biggest use case in IoT. But that's not the only one. We have seen use cases that leverage production optimization procedures, especially the PDCA. It's called Plan, Do, Check, Act cycle, which is also sometimes called Six Sigma process for Deming and HIOT cycles. These are elements of data collection at various points within a manufacturing process that ensures high quality of the products that are being developed. Flexible manufacturing, many manufacturers with multiple manufacturing factories, for example, spread across in the globe, when these factories are specialized in creating, say, multiple components that will eventually get assembled into the final product, it's very important to understand the and delegate what they call the demand into these factories for what they call flexible manufacturing. That means they can switch one factory to take up one particular component more than regular workload to cater to a seasonal demand, for example. So such flexible manufacturing is also usually a typical use case in IoT and IoT. AR, VR assisted workplace, many manufacturing units, especially when it comes to training and maintenance, training a new individual on operation of a machine, AR, VR is the answer that reduces their training cycle or error, human error, drastically with AR, VR capabilities. Definitely other elements within IoT are relevant to digital twin implementation. Digital twin is more of gathering data and leveraging data to simulate futuristic use cases in production optimization scenarios. Typically, we use the digital twin architecture or digital twin use cases to simulate a copy of the entire operation within a factory and work out scenarios where future demand can be met with a different algorithm within their factory operations. So important for us to understand is actually developing the right business case for our organization is the most important first step in developing an IoT project or a pilot. In the case of IoT, the most important feature one can consider is, of course, connectivity or the lack of connectivity thereof. Wherever you see a business process within your organization that is not connected in real time, that means something is happening within the business process, but that insight is not readily available for decisioning. So those are areas where a lack of connectivity of the business process with the decision makers could be a scenario of your IoT-based business case. Definitely lack of intelligence. That means you don't have data on hand immediately to make sensible decisions. Another end, sometimes there is no sensory data available. So that means we need to implement new sensory information. In most cases, definitely the dynamic nature of the business process itself will dictate if it's a good use case for IoT. And IoT also is the first and foremost step to collecting and converting data in such a way that means business decisions, or ways that means business decisions can be made out of it. In this whole process, various components of IoT need to change their state dynamically. For example, the input of a temperature sensor will vary continuously based on weather conditions, locations, etc. But an IoT device should be designed this in keeping in mind. So these are the key elements that you can think of when you're trying to identify which business process is a good candidate for putting together an IoT solution within your organization. Another area of putting together a business case for our business stakeholders, definitely ensure that we clearly define the business problem and the opportunity, definitely quantify the benefits in savings or even new revenue models. Define that criteria upfront, how to measure a success within our IoT use case. Of course, enumerate any risks like security, like high costs, things like that. But evaluate multiple technical solutions that you can use to solve your business case. So all these are key elements in your what you call pilot phase or business case development phase that are very important to put on the table, because a lot of times what we have seen with our customers is they embark upon an IoT project. Some of these criteria are not well defined, and they end up in a purgatory. They don't come out of that pilot phase at all. So it is important. Most of these will eventually give you the right ROI as well, if they are thoroughly thought through. With that being said, let's understand what it entails from the architecture point of view when we need to develop any of these IoT solutions that we have talked about, and any of the business cases that we have talked about. Of course, IoT solution revolves around data, and that's an important thing that we have to realize. Of course, at any point of time when we are generating insights to improve a certain business process, it entails collection of data, analyzing of data. Of course, we have to integrate various systems to create those insights for that data, but eventually those insights will allow you to innovate on your processes as well. So the entire use case that we are looking at for any of our business processes have to revolve centrally around data. Data in the form of raw data when it's at the edge, but as it comes into the IT systems or the cloud systems and IoT systems, we have to analyze it and generate insights that will feed back into improving or optimizing the business process that we are talking about. In other case, we have seen organizations that don't really own the data or generate the data. They can actually leverage third-party data sources. That means, you can subscribe to weather.com and get all the weather-related data points of a location, of a region, historical data points, and predictive futuristic data points as well from weather.com, and leverage that data into your own business process improvement. Maybe it's about oil trading or energy trading. That you can leverage that weather information. So yes, you don't really have to go through an edge architecture and implement Internet of Things to get to Internet data or IoT data. You can also subscribe IoT data from third party. So definitely data is still the most important element. The second most important element of understanding IoT solutions is the security. It is very critical. Of course, security of not only data, now we are talking about security of the devices themselves, especially those remotely provisioned devices. So is not only the security of the data in the form of encryption and authorization, but safe and timely arrival of data is also very important in IoT use cases, because most of the time we are talking about real-time data insights. So is it necessary to periodically update the software on the device? That's another big subject, because most of the time the device level software, the edge level software, I'll talk about that in a little bit later, is what we call the real-time operating systems. They are being plummeted nowadays because of the proliferation of the devices and the growth of the Internet of Things devices. Security has always been on the back burner for rapid time to market. So definitely we need to give a lot more attention to device security and the operating system security of the edge devices. So device security is number one. Number two is the network security itself. That means from the edge to your cloud and IT systems, how are you ensuring security over the network, whether it is TLS, whether it is public key infrastructure, and sometimes even device authentication will dictate what kind of security you can layer up. Another layer of security is, of course, data protection as well. Many connected devices will be storing and transmitting sensitive, personal, identifiable information. Companies that fail to protect this data may not only face adverse business impact, but also nowadays regulatory penalties as well. So enterprises should enforce data encryption for application and user data for what we call both in-flight data and data at rest. So that's an aspect that the architecture should take care as all three levels of security in protecting the data and access. So beyond those core elements of data and security, the architecture is typically structured this way. Typically in any IoT solution, there is an IoT edge, which can have sensors, devices, machines, and sometimes even certain gateways that will bring together all these sensors and machines and devices together for getting connected into the internet. Then there is an aspect of connectivity itself, how those that edge gets connected into the cloud or into the what you call IoT systems, or you can say IT systems. And we'll talk about these three different areas in detail in the next few slides. But this is a good start for any typical IoT solution architecture. We have to deal with IoT edge and its architecture in its own isolation. We have to deal with the various forms of connectivity, the right suitable connectivity for us, and so on, but also the connectivity and security that comes in through with the connectivity. And on the other end is pretty much regular IT. Most of the time when we talk about IoT systems, we are talking about either device management, data management, analytics, and of course, dashboarding or IoT applications that will expose the insights or deliver the insights to various business stationing. To start off with, what is that IoT edge, right? An edge is typically the hardware itself, right? Yes, you can have sensors, you can have machines, you can have devices that perform a particular task, and those devices might have additional sensors within them, and how those sensors generate data is what is all about, what is all the edge about. Sometimes these edge also will have local intelligence and analytics available to make decisions locally as well. So at a high level, the sensor, the device, and the gateway, those are the three elements of the edge. Typically, between the sensor and the device, you might have a wired sensor connected to the device, or you might have Bluetooth or Wi-Fi or NFC. Zigbee is a very popular connectivity protocol for home and domestic residential devices. So that means if you have a smart doorbell, a smart smoke detector, all of those talk in Zigbee with the devices. Now, between the device and the gateway, it could be a machine or a washing machine or things like that. We are talking now about a device that actually operates. It has electrical controls and so on. So usually, the device will have some kind of a compute power, maybe a PLC controller. So that PLC is typically connected to the gateway either by a Modbus or a BACnet, sometimes even LoRaWAN that allows for localized connectivity. Now, in the gateways typically an ability for many devices and sensors to get connected into the internet. Gateway is typically the one that will provide the IP for the device or the internet address, MAC address for the device. We have seen many gateway manufacturers, a plethora of them. Of course, Dell and HP are big players, but Semtech and Advantech are upcoming hardware manufacturers that support a lot of those gateway protocols as well, especially LoRaWAN and local wide area network and Bluetooth-based home appliances. Those are elements that the gateways are very popular with. On the far end, the edge, of course, whenever you have hardware, you need to have software or firmware, or typically we call it the RTOS, real-time operating system. So these operating technologies, of course, AWS Greengrass and Azure IoT Edge are becoming popular nowadays. But Cumulosity IoT has extensive edge agent capabilities. Foghorn and Kuxa, Eclipse-based Kuxa is open source RTOS, and of course, Raspberry Pi and things like that are also quite popular in developing RTOS technology and firmware technology on those devices. Most of the time, what kind of software programs these devices contain is, it's typical machine state programming, or state machine programming. That means, if this switch is on and the sensor says this, turn the switch off or things like that, right? So if and else kind of programming, C, C++ is also very popular in those operating systems. Now, coming to the middle layer, connectivity. So understanding the connectivity that is suitable for our business use case is very, very, very important. Most of the time, your overall return on investment into your IoT solution depends on the right selection of your connectivity. A lot of times we have seen connectivity is the biggest cost factor in a successful IoT implementation and adoption. So connectivity goes in many ways. Of course, we have what we call local area connectivity options with WAN, Sigfox, and LoRaWAN. We definitely have wide area connection options with, of course, cellular, GSM, 3G, 4G, and BIoT are a few other aspects. 5G, which is a new kid on the block, is definitely a game changer nowadays. It is still in its early stages, especially for IoT side implementations, but definitely it will open up a lot more use cases and business use cases for IoT with its capabilities. And on the long range, when you need to have a sensor in the middle of the desert, satellite-based long-range options are also very popular in business use cases. So just wanted to touch upon that 5G because that's probably what you will run into and leverage in the future for sure. So 5G comes in multiple flavors. The MMTC, the massive machine type communication, is typically for very high density, deep coverage and long battery life kind of implementation. When we say very high density, just imagine, within a few square meters, or few less than, maybe in a factory. In a factory, if you have sensors, and we are talking now about 1 million sensors. So when there is a very high density need for a 5G to cover, to actually connect to very high density sensors, that's when we use MMTC. On the other end, EMBB, or enhanced mobile broadband. It's typically for data capacities, maybe streaming, maybe deep awareness of the machine itself. So such use cases, we leverage EMBB. And the last one, the URL LC, or what we call ultra high reliability and ultra low latency communication. These are for very specifically mission critical control. As the name suggests, they are very highly reliable. That means a device makes a connection to a 5G router. The connection is never lost. It is ultra high reliable. And on the other end as well, ultra low latency. That means, sub millisecond latency in the data transmission. Usually, for example, if a surgeon wants to operate on a remote operation, that's when we will definitely use URL LC. Because of that high reliability of the connection and the lowest latency. So those are important things that we can put in our reading material to read more about what are the right connections that we would want to leverage for our business use case. Data throughput, massive connects, low latency are the key elements of connectivity that will dictate what we're going to choose. And of course, definitely cost matters as well. So, but as we can see, the 5G is becoming very prevalent nowadays. We are hoping to see a lot more cost benefit there as well. Now, coming to the last portion of our architecture is to talk about the IT side of the IoT solutions. We covered the edge, we covered the connectivity. How do we do with IoT systems themselves? How do we develop various IoT solutions on the IT side of the bandwagon? So typically, you have two options. You can build from scratch on an infrastructure as a service platform like AWS, like Azure IoT or AWS Greengrass. But here you are pretty much building, a custom solution. You're building the blocks. You have the blocks. You're just building the entire solution from scratch, pretty much. But it provides freedom. It definitely provides the freedom to choose a suitable architecture. It allows you to pick your own technology stack that you will be used for data analytics and dashboarding and such. And all major infrastructure as a service vendors of course, AWS, Azure, and GCP. They all have capabilities that can allow you to build from scratch. On the other hand, you have IBMs, you have Software AG. Software AG Cumulosity is very popular. You have PTC ThingWorks. These are the prominent players in the market. What they are, of course, they are off-the-shelf software, ready to use, rapid time to market, low initial investment, and so on. Definitely, they're moderately priced when compared to custom development product, because overall total cost of ownership is more important to measure than the initial purchase price itself. So quickly, yes, these are some elements that you can compare, these platforms versus your infrastructure as a service providers. I think time to market, definitely platforms provide a lot of advantage. And a lot of the things, you don't have to reinvent the wheel, right? When it comes to device management capabilities, you don't want to build that. Those are already available, definitely scalable. Another area that you have to look for is support. You would get a lot more support from a platform vendor who have developed these platform purpose built for these solutions, and definitely cost of the solution overall. In long term, in overall cost of ownership of the solution, built from scratch definitely comes out higher, unless you're a technology company, want to develop things on your own. It will make a lot more sense for you to leverage and buy off the shelf platform. So with that said, I would like to introduce you to Software AG Cumulosity IoT. I think Forrester names Software AG as one of the providers that matter most, and specifically the industrial IoT software platforms market. The foundation for Software AG's IoT application platform suite is actually Cumulosity IoT platform. The platform natively provides capabilities for specifically device management, data management, and other competitive capabilities relating to integration, analytics, and security. Cumulosity IoT can be used standalone or in conjunction with other products in Software AG's digital business platform portfolio to take advantage of course, improved analytics, data management, and integration capabilities. I think Software AG also brings and allows readily integratable components like Apama and Gementis for data analytics. It's web methods platform that allows you to integrate extensively with any of your backend systems to bring the insights together. So those are huge strengths for Software AG. And I think recently as 2017, 2018, Software AG also entered into a joint venture with some of the largest machinery manufacturers for Industry 4.0 and manufacturing sector. I believe DMG Mori, Dur, GES, ASMPT are some of the key manufacturers that have adopted Software AG Cumulosity to create an open, non-proprietary, Industry 4.0 platform ecosystem. It's kind of an ecosystem where if you buy a DMG Mori robot for your paint line, it already comes with Cumulosity agents. That means you just take your Cumulosity platform, open it up, configure, and you're connected. And some of the elements are already there for you to start now developing rapid Industry 4.0 use cases. So this network that is formulated by these manufacturers is called ADAMOS, ADAMOS. I think it's based out of Zurich or Germany. But yeah, it is an adaptive manufacturing open solutions consortium that allows you to integrate heavy machinery and all pretty much major machine manufacturers are part of that network. Cumulosity has a extensive scalability and high availability. I think it is tested with more than 8 million devices. It can of course scale elastically. It is available in multiple deployment models. Definitely, you can subscribe to the public cloud model. You can migrate between public and private cloud. You can create your own private cloud as well. And Cumulosity also can be implemented in your own network if you want to control and keep the data within your private data center. That is also a possibility. Another area, Cumulosity platform comes with a multi-tenancy model. What that means is typically if you're an organization that is building devices that are internet devices, IoT devices, and you're taking to market, and sometimes you need to manage multiple customers within their own tenant systems. That's when a multi-tenant architecture for the platform is really crucial. So you can definitely leverage that true multi-tenancy that is available within Software AG's Cumulosity. I think there is one success story that I'll talk about in a few minutes that is definitely implemented leveraging Cumulosity IoT. Before we get there, I just wanted to quickly, give a high level on the other platforms. Of course, as I said, Microsoft and Microsoft Azure and AWS IoT, they are the infrastructure underpinnings. They are the IaaS vendors who bring in what we call IoT capabilities to the table. So Microsoft has ambitions to play a bigger role in the industrial IoT space, and in its own right, it does offer a comprehensive set of development tools where you have to leverage those tools to build your own overall solution. Same case with the AWS platform as well. It spans a lot of capabilities for analytics, device management, and edge services. AWS also has what they call, they released, I think in 2017, they released Greengrass. It provides edge devices with compute and messaging and machine learning capabilities that work alongside equivalent services in the cloud. On the other end, IBM Watson IoT platform was, I think it's quite old as well. It's generally available since 2015. It has its own various flavors of capabilities that it brings to the table. The Watson IoT platform is deployed as a public cloud service, kind of a multi-tenant, and sometimes even a dedicated cloud service for on-premise deployments. Of course, the platform's capabilities include leveraging open source technologies, such as even Spark and Apache Agent is one other open source that IBM leverages for enabling some of its capabilities. PTC ThingWorx is one other commercial technology. It's more of a platform than an infrastructure as a service. So it does come as a platform. I think PTC acquired ThingWorx in sometime 2014 or 2015 and brought it together into a viable platform. So PTC's strengths typically lies in, again, in manufacturing sector, based on its core applications for their PLM and computer-aided design. PTC also has these software for CAD and SLM, service lifecycle management, and sometimes even ALM systems for manufacturing sector. So their strength comes from applying CAD and PLM integration into their ThingWorx IoT platform. With that said, I'll quickly, before we jump into our success story, uh, this is our experience. And what we have taken our customers through is typically start off with a feasibility workshop. We do some strategic planning around the business processes and the objectives of the business processes to develop a thorough business case. In the business case itself, we will determine what kind of an implementation roadmap we have to lay out. Definitely, we start with a pilot project. We prove a lot of gate checks that are not only technical gate checks, but also gate checks that will ensure the buy-in and the ROI. Once the pilot is proven, we go into a full-fledged implementation where then the solution is matured for scalability. This one client that I would like to talk about is a access control and a security solutions company. They have a global market. You can consider them, they manufacture smart door locks, key fobs, and their customers are typically these large hotels that want to implement keyless entry into their hotel rooms. So they are not only, of course, not only hotels, but they serve large enterprises as well, like airports and other secure facilities. So access control, people movement is their business. Opening the door, closing the door, remotely controlling that access is their business. And traditionally, their architecture was, with an on-premise servers and all the cross-referencing between the badge and the door that needs to open the badge that needs to open the door, and so on. But eventually, the IoT side of the architecture is to ensure what we call remote monitoring, remote control of these solutions. What we took through the same journey. We did the initial strategy planning. We laid out an implementation roadmap. We immediately started off on the pilot project, created the pilot where we were involved in firmware development of the smart door fobs and other edge hardware. We also are involved in developing their own form factor for their gateways that can be installed on premises. So these gateways will now then establish connectivity into the cloud solution. The cloud solution is of course architected to be cloud neutral. That means the cloud-based IT components can be provisioned into any cloud depending on the geography. That means they are both AWS and Azure friendly architecture and independent as well. And at that stage, the end-to-end solution is matured into a highly scalable solution, multi-geographical deployment architecture. That means the platform can be installed for China in Baidu, for Europe in AWS, and for North America in Azure. But all of them still be maintained and managed through one lifecycle. So that's a huge success story. Now we are in the scaling phase of the solution, where the customer is planning to deploy this multi-tenanted architecture solution into various geographies across the globe. I think what we have done for them is definitely a huge success. They had their own growing pains as well. Before we got engaged with them, they were dabbling with the architecture for a year and a half, trying to solve the problems on their own with their own internal team. It's not that their internal team is not capable. It's just that they didn't have the right exposure for the technology that is available, or the trends that are materializing in the ever-changing IoT technology. So when we got involved, we allocated the right attention to the areas of what needs to be done, all the way from elaborating upon the business case and the criteria for success to gradual, as we said, small steps, think big, take small steps. So that's what is our success with this project. We took step by step. We eventually reached a good journey and a threshold where we are right now aggressively scaling the solution into multiple geographies. With that said, I would like to open up for question answers. I think we have 5 minutes. I hope we have enough questions that I can address. Jatin, do you have any
Yep.
thoughts coming up?
Just an announcement. Please, for the audience, if you have any questions, use your Q&A button on the panel, on your Zoom panel, to send us on your questions. So I have one question, Ram, which says, is infrastructure as a service or a platform as a service would be a better time to market solution? Any thoughts on that?
Definitely platform as a service, like software regis cum laude, has the quickest time to market. The reason is they are purpose built. They have, say, for example, the device management, components and the facilities and features developed for purpose. They might also have the right scalability architecture when it comes to, again, device management is not the only component within an IoT solution. We need to understand how we are collecting the data, how we are storing the data, how we are analyzing the data, and what kind of dashboards and insights can be generated and provisioned for eventual use. So all those components are brought together into a cohesive platform that is well integrated. On the other end, your infrastructure as a service providers like Azure and AWS, they have these features that are multiple components that need to be brought together, right? Yes, in this case, it's something like open source, right? You're dealing with more of the open source components on the infrastructure as a service components, where you might end up developing a lot of the core functionality, from the scratch. Kind of, you're reinventing the wheel. So there is the time to market is definitely higher on the infrastructure as a service side providers.
Yep. Thanks. And we have one question from Martha, which it's been asked, how do you determine the length of your pilots?
That's a really good question. So I think the customer success story that I talked about, it's an extensive business use case. They are not just reinventing their business model. They are trying to create a new business revenue stream as well. So the business case was elaborate. So we took almost 3 months for the entire pilot phase, all the way from whiteboarding their business case, whiteboarding all the technology gate checks, like what kind of technology we'll leverage for the edge, what kind of connectivity we will leverage for the overall solution, what would be the gateway design, what would be the IT systems design. All those did take time, but in a typical use case, if you're dealing with a small use case, our program, we have a rapid pilot program, a quick start pilot program that usually is less than 6 to 8 weeks. So within 6 to 8 weeks, we should be able to develop a business case, whiteboard a high-level technology architecture, identify the right gate checks, and prove those technology gate checks with the pilot implementation, and go forward into solutioning phase. So I would say if we take more than 8 weeks for the pilot phase, we should be doing something wrong, unless we are actually handling a very large business case.
Yeah, probably we have one last minute. We can take one question. It's about, do you think connected cars provide a good use case to target marketing content?
Connected cars, whether it's Tesla or Volkswagen, these are highly mature solutions that are well vetted before they come into the market. Now, when you say, is that a target for marketing? What we have seen is definitely connected cars are becoming more connected. For Tesla, it is connected. You can see where your car is at any point of time, but also you'll get your real-time updates on the firmware as well, when it's parked in your garage. But that just is the least usage of connectedness. We have seen use cases where the industry is developing how a car will interface and interact with the intersection that is approaching. That means these connected cars now will have the ability to detect that a green light right now on the intersection that they're approaching is going to turn red within 3 seconds. As a human, we don't know that. We don't have that insight. We see a green light. We don't know that it's going to last for 4 seconds. But a smart car that is approaching the same intersection will have the ability to know, yes, it's going to go red in 4 seconds. Maybe I need to speed up a little bit or whatever, right? So what we are talking about is connected cars will start interfacing into connected interchanges or connected intersections or smart intersections, smart lights, smart displays. That means tomorrow, you'll be driving in your smart car and the billboard will be talking to you, right? Or billboard will display an advertisement that is very relevant to you. So there it is. Yes, there is a huge marketing opportunity for connected cars that they can sell their insightful data for marketing and advertising.
Yep. I think that's the time we have. Ram, thank you so much. And for the audience, as we mentioned earlier, we will be sending out the recorded version of this webinar and the PPT deck in the next few days. If you would like to start any new conversation, please email us at ask@keltontech.com or visit our website at www.keltontech.com. Thanks again all for joining us today. Bye-bye and have a good day.
Thank you, Jatin. Thank you very much all. Thanks for joining us.
Bye.